Hi students, in our previous video we had started the chapter solutions in the second year and we had discussed in the solution the major part or the component it is called as the solvent, whereas the minimum component present in the solution it is called as the solute. And we had also discussed about the physical state of the solution, that is depending upon the nature of the solvent. And now in this video we are going to discuss how to express the concentration of the solution. How to express the concentration of the solution. See, the components that are present in the solution, they are going to decide the concentration of the solution. The components that are present in the solution are going to decide the concentration of the solution. For example, we have discussed in yesterday's class like solute is the one which will be present in a minimum quantity in the solution. Solute is the one that is present in the minimum quantity. If the solute that we are going to give in the solution is very less in amount, when the solute is present in least quantity in the solution, then those kind of solutions we are going to call as a diluted solution. We are going to call them as a diluted solution. What are we going to call them as the diluted solution? In the diluted solution, the amount of solute will be very least in quantity. But if the same solute is present more in amount in the solution, when the solute is present in more quantity in the solution, such kind of solutions they are called as the concentrated solutions. Here solute amount will be more in the solution. It is called as the concentrated solution. But to speak these two, diluted or concentrated, we are not giving how much exactly the amount is present. We are discussing it is present, but how much it is present we are not giving. This kind of method it is called as the qualitative method. What is this one called as the qualitative method? We had already discussed in the first year. Qualitative method explains that what is present in the solution, but it will not give how much of the amount of the substance is present in the solution. So this qualitative method cannot decide exactly the concentration of the solution. For that purpose, we are going for the quantitative method to express the concentration of the solution. What are we going to use? Quantitative method to express the concentration of solution. This quantitative method that we are going to study now, it is of different types based on the state of the solute and also on the solvent that is together, that is forming the solution. So let us go on how these are classified further. Let us see this concentration of expressing the concentration of solution quantitatively. There are many methods. Among them, the first one we are calling it as the mass percentage of the component. What are we calling this as? The mass percentage of the component. There are two components in the solution. There are two components in the solution. We had seen, because we are discussing about the binary solutions. What kind of solutions we are discussing about? The binary solutions. Means solution is made up of two components. Solution is made up of two components. In this, one will be solute and another will be the solvent. So this solute plus solvent together, they are giving the solution. What are they giving together? The solution. Now, if you want to know how much of mass percentage of either solute or solvent is present in the solution, we are going to use this method that is called mass percentage. Means we are going to express the solute or solvent in the form of their grams. In the form of the grams as a unit. So let us see the formula here. The mass percentage of the component. What is meant by the component here? It may be a solute or it may be the solvent. So the mass percentage of the component is equal to mass of the component in the solution. Mass of the component in the solution by total mass of the solution. By total mass of the solution into 100. This is the general formula to express the mass percentage of the component present in the solution. Now let us take one example. The example what we are using is, there was given as 10% of glucose solution in water. Mass percentage, mass by mass percentage is given as, see, 10% of glucose in water, mass by mass percentage is given as. Here glucose, how much they mentioned? 10% they had mentioned. Mass by mass is the main thing we want. Means mass of the solute and mass of the solvent we are using. What is the solvent here? Solvent is the water. Solvent is the water. Then what is the solute? Glucose is the solute. How much amount they are mentioning? They had already mentioned 10%. 10% of glucose is nothing but 10 grams of glucose according to the mass by mass percentage. 10 grams of glucose is dissolved in 90 grams of water. 90 grams of water. So once we know the percentage, mass percentage of one of the component, we can say from 100, if you remove this one, the remaining component will have that much of percentage, or we can express that in the form of the mass. So what is meant by 10% of glucose? Means 10 grams of glucose is dissolved in 90 grams of water by mass percentage. If that word is not given, we don't know whether it is volume or mass. So it is measured mass by mass percentage is the one we need to express. So in the mass percentage of the component in the solution, mass percentage of the component, you want to calculate the mass percentage of glucose. Mass percentage of glucose in this solution. Then you can see mass of the component in the solution. What is the mass of the component that is solute in the solution? 10 grams. So shall we say 10 grams of glucose, 10 grams of glucose by total mass of the solution. How can we give total mass of the solution? We need to give mass of the solute plus mass of the solvent. Mass of the solvent means how much we had? The mass of solvent 90 grams into 100. So this is nothing but the 10 by 100 into 100. 10 by 100 into 100. So how much you are getting the percentage? You are going to get the 10%. This is used in the industrial purpose, commercial industrial purpose. What is commercial industrial purpose? For example, the water reservoir is there, or our town is having water treatment plant. In that water treatment plant, we need to purify the water from the germs or microorganisms. In that case, they apply the sodium hypochlorite. What do they apply? Sodium hypochlorite. This sodium hypochlorite is applied to the water to disinfect it. How much it is applied? It is applied as 3.62 mass percentage. How much it is applied as? 3.62 mass percentage in water. So this is the industrial application of applying mass percentage, in which mass of the solute and mass of the solvent are together expressed in grams, and mass of the solution is also expressed in the grams. Let us see the next one. Let us see the second type of expressing the concentration of solution. In this, the percentage we are going to express in the form of volume. How do we use the volume for which state of matter? Generally it is applied for liquids. It is applied for liquids. So the solute and also the solvent together they are making a solution which are in the liquid state. For such kind of liquid solutions, we apply the volume percentage. For the liquid solutions, we apply the volume percentage. What is the definition and formula we can give here? The volume percentage of the component, maybe solute or solvent. Volume of the component by total volume of the solution into 100. The formula what we use here is volume of the component is equal to volume of the component by total volume of the solution into 100. For example, it was given as 10% of glucose. Already we had used glucose, so we can take 10 ml of ethanol in water. Volume percentage is here they are asking us the volume percentage of ethanol. Ethanol is present in which state? Liquid state. Water is present in which state? Liquid state. Ethanol is the solute we can call, and water is the solvent we can call. So when the solute is in the liquid state and solvent is also in the liquid state, the solution, what kind of solutions we call? They are called as the liquid solutions. What are they called as? The liquid solutions. So let us see 10% of ethanol means 10% of ethanol means 10 ml of ethanol is dissolved in 10 ml of ethanol is dissolved in 90 ml of water. 90 ml of water. So we can say the volume percentage of ethanol. Volume percentage of ethanol is given as 10 ml of ethanol by 100 ml of solution into 100. How did we got 100 ml of solution? The solute is 10 ml, solvent is 90 ml. So we got 100 ml of the solution, which is known as the 10% of the ethanol. Generally, in the cars, the batteries they use, they must withstand the lower temperatures. Even in the winter season, this battery must not be freezed. So, in order not to freeze this battery, in that there will be added a compound that is called antifreeze. The application where we are using this one means the antifreeze we must use. What is the antifreeze compound they are using here? Means it will not let the water that is used in the battery to be freezed at 0 degrees Celsius. The compound that they are going to add here is ethylene glycol. What is the compound they are going to add here? Ethylene glycol. This ethylene glycol will reduce the freezing point of water up to tolerate up to 17.6 degrees Celsius, or you can say 255.4 Kelvin. How much of ethylene glycol are they going to add? They are going to add 35% volume by volume of ethylene glycol in water. How much? 35% volume by volume of ethylene glycol in water. 35% volume by volume means, can you could say 35 ml of ethylene glycol is added to 65 ml of water to give 35% of volume by volume. Very important objective question. This is used as the antifreeze to prevent the battery to be freezed at lower temperatures. The third presentation of concentration of solution is mass by volume percentage. What is this one? Mass by volume percentage. Where do we use this one? Generally, this mass by volume percentage is used in pharma and medicine industry. To express the amount of solute in grams to be dissolved in amount of solvent in ml. What is the point here? Solute is expressed in grams, whereas the solvent is expressed in ml. Hence, this kind of solution, its percentage is going to be expressed as mass by volume percentage. Means solute will be expressed in the mass, that's grams. Solvent will be expressed in the volume, that's called ml. So this is a very simple mass by volume percentage is used in pharma and medical industry. Thank you children. In the next video we shall continue about mole fraction.